To wrap up our topic 12, we are back today in 12.8 dealing with congruence transformations. So, big idea here is that we can use the composition of rigid motions. Now, big thing is rigid motions. Remember that rigid motions means that it maintains the size, the angles, the distances, everything on the shape stay the same except for where the shape is actually located. So, that keeps it congruent. So in the first got it, make sure that you've worked through the first part of the lesson before coming to the got it, and then try this on your own. We want to list all pairs of angles and all pairs of sides that have equal measures between A, B, C, and X, Y, Z. The composition that happened was a transformation, 2 to the right and 3 up, followed by a rotation, a reflection, of this line here. What this composition is, what the rigid motions are, don't really matter. All that matters is that we can identify what matches with what. A matches with X because it's first point to first point. B matches with Y because it's second to second. C with Z because it's third to third. And then we start matching up the sides. So when I start my sides, we have AB congruent to XY. Then I would have BC congruent to YZ, second, third. And then I would take my third and my first and have CA or AC congruent to XZ. To try this extra practice problem, we have a translation 4 down and 6 left. 4 left and 6 down, and a rotation 180 degrees about the origin, but nothing has changed the size, so we know that HJK got mapped to PRS, so we have our pre-image and our image. We want to list all our angle and our side pairs with equal measures. So we can do the same thing again to match up our points, H to P, J to R, and K to S, and then we can do the same thing with our sides and get our congruence sides there. How do we know that two figures are congruent when something has happened to them? Well, they're only congruent if and only if there's a sequence of rigid motions, no dilations allowed, no change in size, that maps one figure to the other. I wanted to take a second to say that maps here is referencing the moving of a figure. So make sure you've worked through the next section of the lesson to make it to this point. Now, we have actually a couple pairs of shapes in the got it that map to each other. I want you to pause the video and check if you can list the order of the points in the correct order. That's the biggest mistake that I see, and it's going to happen with the triangles. If these triangles are congruent, you need to list them in the correct order. And looking at these triangles, the big thing that I have to match up is QM with UW, and see that that's because we go 2 down and 2 to the right, and we go 2 down, 2 to the left. That tells me there's going to have to be some kind of reflection. Notice that their angles of the slope of the lines are kind of perpendicular to each other. So that tells me that there's going to be a reflection. So we start by reflecting the x-axis, and then I translate left to make it over to the shape that I need, and that then lets me line up the points in this order. As long as U matches Q, V matches N, and W matches M, you are correct. And likewise, probably a little bit easier, we can see that A, B, C, D matches to H, I, J, K just through a translation to the right and down. In 2 and 3, you want to identify a pair of congruent figures and then how we mapped from the pre-image to the image. So a good thing when we're looking at just an individual line, if you can't figure out the distance, like a diagonal line has a kind of difficult distance to figure out the change that happens. So I go 1, 2, 3, 4 over, and then 2 up. Let's see what DF does. If I go 1, 2, 3, 4, and 2 up, so these lines will have the same distance. If we compare it to AR, we go 1, 2, 3, 4 over and only 1 up. That means AR will not be congruent with GC and DF. So now all we have to decide is what maps it there, and we actually have a few different options depending on how you look at it. I think about it as reflecting around not necessarily the y-axis, but a line like the y-axis. If we use the y-axis, then it would have to translate right and down, or if we use the line x equals 1, we could just flip it right around there, then translate left and down. Then in number 3, we should be able to easily identify which two quadrilaterals here are congruent to each other. We see this kind of odd-shaped one seems to match the other odd-shaped one. This one that's closer to a rectangle is obviously not the correct shape. So you see there's going to have to be some kind of either reflection or rotation, and since I notice my short segment is on the right side, and my short segment here is on the left side, my diagonal segment off of the short matches up with this, so I'm on the bottom, then I'm on the top. So we see we're actually going to need to perform a 180-degree rotation to get this to the left and this from the bottom up to the top. Whole thing needs to spin, so we end up doing a 180-degree rotation about the origin. One of the biggest mistakes I see is people going in the wrong order. So in this got it, please make sure you pay attention that we're going from our shape NAV to our new shape BCY. So N will map to B, A will map to C, and V will map to Y. What you should see is what starts on the left stays on the left, what starts on the right stays on the right, but what starts on top goes down to the bottom now. So that should indicate to you the orientation of the triangles. That should indicate to us that there's going to have to be a reflection. So we can reflect across the x-axis and then just translate it to the left 5 units. Go ahead and try 4 and 5 on your own. Pause the video and see if you can figure out what rigid motions map from LMN to RST. So you're going from the blue shape to the red shape. With many of these, there are a lot of options that you can take. Not like infinitely many, but there are a good amount. So a sample answer for both of these is a translation to the left, 2, and then a reflection of the x-axis. And then in 5, if we just rotate 180 degrees around, that does exactly what we want it to do. So in this got it, we're asked to think about how we could know that these two triangles are congruent. How can we prove this? Well, I've got TD equal to EN, one side, one side. So what I see here, once I highlight everything, is I have side, 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 which proves similarity, but it does not necessarily prove congruence. I deal with that to prove congruence by saying which points relate to which, and then say that there's a point that we rotated about, because if you look at the shape, you can see there's been a rotation that happens. So we say that it had a composition of translation followed by a rotation that maps the one shape to the other, and since I can prove that that transformation did not change the size, we know that those shapes must be congruent. And I need to correct one thing that I misspoke on. Side, side, side can in fact prove your triangle congruence. I was thinking angle, angle, angle cannot prove congruence. That proves similarity. Try reasoning through number 6 on your own. What we're given is that EK is equal to LH, angle E is equal to angle H, and angle K is congruent to angle L. Sorry, all of these are congruent. I accidentally said equal there. So we can already see that if we're just basing this off of triangle congruence, we have angle, side, angle for both of these. So we know that they're congruent, but we have to use transformations to talk about why they're congruent. If we look at the orientation of these shapes, we can see that S needs to end up matching up with A, E needs to match up with H, and K needs to match up with L, so there has to be some kind of rotation that happens here. So we say that we rotate either EKS or ALH, whichever you want to start with, we can rotate one to the other. Think about number 7 here. Now be careful of the orientation. C is going to map to N, I is going to map to V, and Q is going to map to Z. So since the orientation stays the same except for C being on the bottom, now going to the top, we know that there's going to have to be some kind of reflection that happens here. And like I said, your answers may not be perfectly the same as what I have on here, but as long as your composition of transformations maps from one shape to the next and keeps the size the same, then you are good. Take a second on this got it to pause the video and write out why these figures are congruent or are not. Hopefully you notice that this is not a visual trick. These two figures are not the same size, so that means that a dilation would have been involved here, so no, they are not congruent because congruent shapes must maintain their size. Determine whether you believe 8 and 9 are congruent, and if so, why? If not, why? So for number 8, I could drop a line straight between these two lightning bolts and see that yes, they are congruent because it is just a reflection. In number 9, it might be a little bit harder for you to see. That's why I drug the ruler out here. So notice this is just over 2, whatever our units would be there. Then I'm going to spin the ruler. Then I can see that my other part is over 3 tall. So they are not congruent because there's no congruence transformation that would make that mapping happen. And our last problem here for today, look at the graph here to the right and determine what 2 shapes are congruent to each other and what is the congruence statement for that. So you have to match your pairs up correctly. Hopefully the heights of the triangles or the design of the triangles gave it away that this being actually an isosceles triangle does not match up with my other 2 triangles here. So you have to think about then what else is the congruence transformation that relates them to each other. Again, when we look at our congruence transformations, we have options for how we get from one figure to the next. But what matters here is that R has to match with Q, A has to match with S, and V has to match with I. Please make sure that you understand how we match up these points and what it is we analyze when looking at this to determine that. Please do the practice because that's the only way you'll get better at this. And let me know if you have any questions, comments, or concerns from any of Chapter 12. Aside from that, I will post the answer key online so you can check all the work that you've completed. And please let me know if I can do anything at all. I will see you in class. Be ready for your test. Have a great day.